Okay, hi everyone. Today we'll be going over elementary and non-elementary matrices. So let's define them. Well, what does it mean for something to be elementary? It means easy, right? And that's pretty much what this video is going to be about. So elementary row operations can be defined as switching rows, where you switch row 1 with row 2. It can also be multiplying a row by a non-zero constant. So it can be 2 row 1 plus row 2, and you can move it to row 1. Or it can also be just multiplying a row by a non-zero constant, which is just 2 row 3 to row 3. The definition of an elementary matrix is such that in an n by n matrix, a matrix is considered elementary when it can be obtained from the identity matrix I sub n by a single row operation. What do I mean by that? Let's start with a numerical example. So, is this matrix elementary? And it does look very similar to an identity matrix, so that's a good clue. Think about that for a minute, and then I'm going to explain the answer or the solution. And it turns out that this matrix is elementary. In order to obtain it from the identity matrix, say we have the identity matrix with a diagonal of 1s. This was obtained by multiplying row 2 by a non-zero constant of 3. Therefore, this matrix is elementary. Okay, so say we have this matrix. Is it elementary? Well, for starters, we need to see how it deviates from the identity matrix. However, when n is equal to 2, the identity matrix should be a 2 by 2. Therefore, this is a clear indicator that this matrix is not elementary, based on the fact that it is not a square. Now, what about this matrix? Is it elementary or not? Well, it's a square. It looks very similar to identity matrix. Let's think about that. If we have the identity matrix as given, we have to multiply the third row by 0. Therefore, it's row 3 times 0. However, we establish that when it comes to multiplying a row, it has to be by a non-zero constant, in which this example violates, and therefore this matrix is not elementary. Now, what about this matrix? Well, let's draw an identity matrix for reference and see if we can connect the two. So, it looks like both matrices have 1s and 0s. They're both squares. That's pretty good so far. And if we were to look at the identity matrix, all it's done is that it swapped out row 2 with row 3. Did you guys catch that? Well, because this matrix simply swapped the rows, it abides by the three rules to determine elementary matrices. And by switching rows 2 and 3, this makes the matrix elementary. Now let's do a 2 by 2 matrix, and we're given the same objective. It helps to connect the matrix to an identity matrix. So, is this matrix elementary? They're both squares. That's good, and there appears to be a 2. I wonder how that got there. So let's see here. If we were to look at the identity matrix, how did they get 2? It turns out that the identity matrix, the first row was multiplied by 2, and it was simply moved to the second row. And because this is a single operation, and the first row in the identity matrix was multiplied by a non-zero constant, this confirms that the given matrix is elementary. Now, is this matrix elementary? So, in the past, we've connected the elementary matrix to the original matrix, but what if we grab the given matrix and transform it into the identity matrix? Now, if we were to do that, if transforming the given matrix into the identity matrix takes multiple steps, does that make the matrix elementary? And it turns out it doesn't. It has to be done in a single operation. And if we convert this matrix to an identity matrix, well, let's give it a shot. So, first off, the second row was divided by 2. And therefore we have 1, 0, 0, 0, 0, negative 1, and 0, 1, 0. And in order to cement the identity matrix, row 3 was multiplied by a non-zero constant, and therefore we have our identity matrix. Yes, although this matrix can be transformed to an identity matrix, it took more than one operation to get there, and therefore the given matrix is not elementary. We have now concluded how the means of defining an elementary matrix and what makes a matrix not elementary. And these are going to be useful because they will enable us to use matrix operation to perform elementary row operations, and we're going to get to that in the next video.